Up next, we have Jordan Egner-Schnitzler from Material Science, and she will be presenting on filament damage in Bi-2212 superconducting wires exposed by external etching.
I bet all of you have personally experienced or heard of how uncomfortable MRI machines are. Well, that's where my research can help. My name is Jordan Egner-Schnitzler, and I'm a material science and engineering major. Now, some of you may have just gone, I have no idea what material science is, but I'm just going to pretend I understand what she's saying and go along with it. But just to help you all out, material science is kind of the study of stuff. We kind of look at the properties and applications for all different kinds of materials. Within the field, we look at polymers, metals, and even exotic materials such as superconductors. Superconductors are a material that conduct electric current with no electrical resistance, which makes them very energy efficient. So I look at the specific superconductor called Bi2Sr2CaCu2O8-x, which is shortened from the scientific name so it's easily pronounced. It has been seen that Bi2Sr2CaCu2O8-x decreases electrical efficiency in different wire orientations and different stress conditions. So I look at that with the concave kind of pushed together a little bit and high tension kind of pulled apart, and concave kind of bold and otherwise. And opposite. From this, I chemically wear away part of the wire so I can see at the filament inside. From there, I image different sections of the wire and analyze the damage seen on those different sections of the wire. After analysis of the images captured, it was concluded that the concave kind of outer curve of the wire and the high tension kind of pulled apart wire were most damaged. These results can be utilized to improve the manufacturing of the wire by looking at the shape and design of the wire and how they're processed. By improving this, the electrical efficiency can be optimized. Once this has been optimized, these and other superconductors can be placed into things such as MRI machines, since MRI machines are kind of a huge superconducting magnet. So once they're put into MRI machines, that can increase the most common MRI machine, which has a average magnetic field strength about 3 teslas to about 10 teslas. Once this is increased, it'll increase the resolutions of the image captured and will increase the size of the MRI machines, which will make them more comfortable for people. Before today, you may not have known much about material science or superconductors, but hopefully now you know they're beneficial to your day-to-day life. Thank you. Okay, yes.
If there's stress on the conductor, would you change the material in it or just change the angles?
You can kind of change the angle because there's how the wire is constructed, mainly because it's a like silver matrix and then there's filaments inside of it. So how it's structure kind of pulls on those, so you'd mainly kind of change the orientation to making the MRI machines bigger, so you mainly just look at the curve and how it's testing instead of the material itself, because the material itself is what we're looking at to be more of the superconductor and how it's constructed. So you wouldn't quite change the material. You could kind of change other superconducting materials, but it wouldn't be